Okay, we also want to be able to take, or need to be able to take, large numbers and change them to scientific notation, or very small numbers and change them to scientific notation. Here we're starting with checkpoint 3, 5,210,000,000, and we want to change it to scientific notation. I would start by taking the 5 we know is going to end up to the left of the decimal. You have to have a digit out there, a digit between either 1, 2, 3, 4, all the way up to 9, one of those digits. And then the digits come after will be written after the decimal point. So that will be the first part. Again, just one digit out here. And now we have to multiply by 10 to some power. And you know, how are we going to get this number back? Well, to start with, the decimal point is to the right of this 0. And you know, if we write this number with a decimal point there, how many spots did we have to move it in order to accomplish that? And so what I like to do is count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to move it 10 places. So this can be written as 5.21. Actually, we don't need the 0 times 10 to the 9. So to rewrite that, 5.21 times 10 to the 9. And you could check this by adding zeros to the end, moving the decimal 9 places, and you should end up with 5,210,000,000. So that would be the answer to that. Second example has a small number, very small number, so a bunch of zeros to the right of the decimal, then the number. But we want to be able to start, or we need to be able to write this number with 6, and then these numbers to the right, 0.893. So I would take that first, and it's also negative. So we'll put the negative there. So that'd be the starting point. But then we have to multiply it by some power of 10 to give us this number. And like I did before, I try to figure out, well, how many decimal places in order to write it like this did I have to move it? So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So I should multiply by 10 to the negative 8. So it's a little bit crowded there. To rewrite it, that'd be negative 6.893 times 10 to the negative 8. And when you do these on a test, I would check this. I'd take this number, oops, and multiply it by 10 to the negative 8th and see that you get the number you started with. One last example I'd like to go over, and that's writing expressions that aren't in scientific notation, even though they might look similar in actual scientific notation. This number is not in scientific notation because the number part is not 9 point something. It's not between 1 and 10. It's got to be a number between 1 and 10. It can't include 10. The 410 is way larger than that. So basically what you would do is you'd have to write, let's convert this. Let's take just this number part, ignore that for a second. Let's change that to scientific notation, and then we'll deal with this 10 to the 7th. So 410 in scientific notation, that would be 4.1, and we had to move the decimal point 2 places times 10 to the 2nd. So that's another way to write that number. But it's also being multiplied by 10 to the 7th, the original number. So we have to put that in. But now we should simplify it. The 4.1 will stay. But using one of our properties of exponents, 10 squared times 10 to the 7th, we can add those two, and you'll have to 10 to the 9th. So that to convert this to scientific notation, we'd have to change both the exponent part as well as this part to get the number we need.